In Algebra 2, section 7.2, we're dealing with solving exponential equations. So, we have three different properties and then a specific formula. Well, two properties, sets of properties and formula that you'll need to know for this section. The first one being the property of equality for exponential functions, and the last one is the property of inequalities, when we're dealing with inequalities. And this is compound interest. So, make sure to pause this and write it down so that we have it for the next boards. But basically, when I have the same base when it comes to exponential functions, then that means their exponents also have to be the same, right? Because if I have 2 squared, it would equal 2 squared, which is ultimately 4. So if I have 3x equals 3/5, then x has to be 5. X has to equal 5. So if their bases are the same, their exponents have to be the same too. Now compound interest is written here, but it's going to mean more when we actually work it out and fill in. But just remember that T is years, P is the principal amount, R is rate, and rate needs to be in decimal. So they're going to give it to you in percentage, so you have to divide it by 100 to find what the decimal is. That's very important because that's the common mistake that people make. And then N is the number of compounding periods. So if they say compound annually, that means it does it once every year. Quarterly is 4 times a year. Biannually would be twice, so how many times is compounded during the year. And the properties for inequality is very similar to properties of equality for exponential functions. Basically, if the bases are the same, then that means if b to the x is bigger than b to the y, then the exponent of x has to be bigger than y, and vice versa. So if I have 2 to the x is greater than 2 to the 6, then x has to be greater than 6. Right? So go ahead and pause it, write this down. Some example problems for you. So the first one is to solve 3 to the x equals 9 to the 4th. So the base are not the same, so there's nothing I can do to it, but I can manipulate this so it looks like the same x. So same base. So if this is 3 to the x, now I can make this as 9 is the same thing as 3 squared, right? I haven't changed anything because 9 and 3 squared are the same things. And so because this is a power on power with exponents, this is the same thing as saying I multiply, it gives me 3 to the 8th. If you're not sure if you did that right, you can just do 9 to the 4th and it should equal 3 to the 8th. It should be the same thing. So because now our bases are the same, x must equal 8. Because once the bases are the same, then I can just focus on the exponents. This one is the same thing. I have 2 to the 5x. This base is not the same, but 4 is the same thing as 2 squared, right? 2x minus 1. Now on this one, I multiply. I'm going to bring this down. But this is 2 times 2x minus 1. Because this is an equation, I can't just multiply like this, 2 times 4. I have to take this 2 and distribute it to each one because there's a plus or minus here. So this is 2 to the 5x equals 2 to the 4x minus 2. Now that these bases are the same, I can just focus on the exponents. I know that 5x needs to equal 4x minus 2. And then from here, it's just basic algebra. So I would minus 4x on both sides. 5x minus 4x is just x equals negative 2. And of course, you can plug it in to see if it works. Because that's how you check your work, especially if you're taking a test. So go ahead and pause and write this down. I have one more board for you. An investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So basically what this is asking us is to find the compound interest, hence the word compounded. So that's when we're going to use that equation, A equals P 1 plus R over N to the NT. Before we do the equation, we have to actually find what each is worth. So first we're going to start with P right here. The principal is the initial amount that's put into the account. So in this case, it's $4,000. Our R is our rate. So remember the rate, even though it's given to you in percentage, you want it in decimal. So I'm going to take the percentage and divide it by 100. So 5.4 divided by 100 is 0.054. Our T is how much years, and this is 8 years, so it's going to be 8. And N is how many times it's going to be compounded. And this says compounded quarterly, so that's 4 times. Once I've identified all the letters, then I just plug it in and I solve. Don't forget to do the order of operations. So it's going to be 4,000 times 1 plus 0.054 over 8 divided by N, which is 4 times 8. So, sorry, my arm hurts. Order of operations is we do parentheses first, and then in the parentheses we'll do this first. So it's going to be 4,000, 1 plus 0.054 divided by 8, which is 0.00675 times 4 times 8, which is 32. And so this is 4,000 times 1.00675 to the power of 32. So order of operations says I'll do powers first. So I'm going to do it to the power of 32, which is 4,000 times 1.24, which is 4,960.80. So that means this is how much I would end after 8 years if the count gives me 5.4%. Which 5.4% is kind of on the low end, but you would be making close to $1,000. So that is compound interest. So next, number 4, is we're going to solve an inequality. So we're going to the last section of the first board that you got. And from here, we're trying to, just like the equal sign, I'm trying to get the same base because I really can't move anywhere without getting the same base. So I have to turn this same base, but with this in a fraction, it's not helping. So what I'm going to do is I'm going to do 3 minus 2x, and then I'm going to put greater than 625 to the negative 1. So I'm not changing the value, right? It still means the same thing, but now I can focus on getting this the same base. It's just that this is negative. So 625, let's get it. 625 divided by 5. So this is 625 is 125 divided by 5. 125 divided by 5 is 25, no. Yeah, 25, 5 times 5. So this is 5 to the power of 4. So I'm going to rewrite this. I'm going to bring this down because it's already the base we wanted. And this is 5 to the power of 4, negative 1. So far, everything is the same as the inequality. As the equality sign. So I multiply this together. This would be 3 minus 2x is greater than 5 to the negative 4. Now my bases are the same. Because my bases are the same, I look at the property. I have it on my notebook here. So if you want to look at your notes, it says that if I have the base of the same, I do x, I can now focus on the inequality. So now I can do 3 minus 2x is greater than negative 4. And I can proceed to solving for x. Now, I just treat this like an equal sign, except the only difference that when I multiply or divide by negative, like when I want to bring a negative over by multiplication or division, I have to flip the sign. But other than that, I treat it like an equal sign. I subtract 3 from both sides. I end up with negative 2x is greater than negative 7. And then I'm going to divide by negative 2. Because I'm dividing by negative 2, I'm going to flip this sign. So it's going to be here. This is going to be 3.5, right? Yes. Positive 3.5, and this cancels out to x. So x is less than positive 3.5. So the goal is to get the base, and then all this should just be a review from your from last chapters, previous chapters. So go ahead and pause and write this down, and try page 464, numbers 3, 6, and 8. 464, numbers 3, 6, and 8. I will see you in class.